Two smart labels can look almost identical, yet deliver completely different visibility. A BLE label broadcasts. Something else must hear it and forward that observation. A cellular label can communicate through mobile network infrastructure with much greater independence. That difference affects coverage, battery, cost, and the decisions you can make. So do not start by asking which label is best. Start by asking what information your operation needs. Bluetooth Low Energy is not an inferior form of tracking. In a controlled environment with suitable receivers, it can be exceptionally efficient. Imagine 100,000 tagged cases moving through a distribution center. Installing receiving infrastructure and using inexpensive, low-power labels may be far more sensible than placing a cellular modem in every case. But the label does not gain an internet connection merely because it is broadcasting. A gateway, smartphone, access point, vehicle, or compatible device still has to receive the signal. This leads to the most important BLE procurement question. What happens when nobody hears the label? Freight moves through airports, ports, trailers, containers, customs compounds, third-party warehouses, and final-mile vehicles. A headline network size is not the same as useful detection density on your lane. Test the longest gaps between useful observations, especially where a route deviation might carry the shipment away from the normal receiving infrastructure. Now consider a high-value asset crossing Europe through several carriers. The economics change. Cellular becomes attractive when the shipment needs to communicate more independently outside controlled infrastructure. That does not make cellular universally better. It means the value, risk, route, and required intervention time can justify the additional power, connectivity, and cost. A common mistake is assuming that cellular means GPS. They are separate capabilities. Cellular describes how data reaches the cloud. Position may be calculated using GNSS, cellular positioning, Wi-Fi, or another method. GNSS can provide precise outdoor coordinates, but every acquisition consumes energy. If knowing that a pallet reached Birmingham at 14:05 solves the problem, continuously calculating meter-level coordinates may waste the label's finite battery. The architecture landscape is expanding. Ambient IoT aims to connect extremely low-power devices using harvested energy or very limited storage. 3GPP is developing this category in Release 19. Wiliot demonstrates an important lesson. Battery-free does not mean infrastructure-free. Its pixels operate with network equipment and a cloud platform. At the same time, Hubble is exploring terrestrial and satellite connectivity for standard Bluetooth-class chips. These developments could blur the old assumption that Bluetooth only means short-range warehouse visibility, but coverage, economics, and maturity still have to be tested. The most capable future system may not choose one radio forever. It may use BLE for inexpensive warehouse presence, cellular positioning for routine movement, GNSS when an exception needs greater precision, satellite-compatible communications in remote areas, and low-energy modes while stationary. The competitive advantage then becomes the intelligence deciding when and why to spend finite energy, not simply the radio printed on the specification sheet. Do not compare only the price per label. Compare cost per successfully monitored shipment and business outcome, including connectivity, software, integration, support, and exception handling. An inexpensive label that leaves a critical part of the journey invisible may be costly. Evaluate the supplier too. Who makes and maintains the device and firmware? Who operates the platform? Who diagnoses missing observations and integration failures? When thousands of shipments are moving, technical accountability matters. A useful pilot should expose weakness before scale. Test actual packaging, carriers, and difficult locations. Include poor cellular coverage, BLE detection gaps, warehouse dwell, route deviations, temperature exceptions, alerts, and API integrations. Measure the longest gaps between useful observations, not merely the number of successful pings. The purpose is not to prove that a tracker works. It is to establish whether the architecture is reliable enough for the decision you need to make. There is no universally best smart label technology. BLE is compelling where receiving infrastructure and scale support it. Cellular provides greater communications independence. GNSS adds precision at an energy cost. Ambient IoT and satellite-enabled Bluetooth open new possibilities. Start with the operational decision, then choose the least expensive architecture capable of providing the information reliably. read the full comparison at strategic tracking, or ask us for an independent use case evaluation.